Hello everybody. Today we are going to learn about namespaces. Namespace is basically the name given to the portion of file. Suppose this is your file. Every file will have a name associated with it. We consider a portion of file and you want to give the name to the portion of file, then that is called namespace. This is now called namespace, which will have some particular name. Okay. A namespace is a section of file, portion of file that is given a name. When writing a class library, not the function, but a class library, programmers would prefer to use short and common names for the non-member functions and the classes, so that everybody else, whoever uses your namespace, should be able to refer to it with ease. However, short and common names may turn out to be the redundant names selected by the creators of another library somewhere else, or by application that uses the library. Therefore, it is not kept in the open. Instead, it is kept in a file and a portion of file, and the portion of file is given a name. This can lead to name clashes and generate multiple definition errors from our compilers. To avoid the name clashes, we implement namespaces. Namespaces solve this problem. Note that member functions don't cause name clashes because their scope is limited to the class, and class is in the namespace and namespace is in the file, so you have a very good rule of scope. Now, defining a namespace is very easy. Have a look at this. Namespace geo. Namespace is a keyword which is used to create the name of the namespace, and the name of the namespace in our case is geo. So we have created a namespace with the name geo. Inside the namespace, we had declared a constant, and we have declared a library function. The function that is kept inside the namespace becomes the library function, which could be used by any C++ developer who have access to the namespace geo. They will use in the beginning of the program namespace geo. Certainly they will have access to pi, and they will have access to circumference function. Now, braces delimit the namespaces. Any variables and constants and libraries declared within the braces are called namespace members. This is a namespace member. This is a namespace member. Okay. Notice that there is no semicolon following the closing brace here, as there is with class. With the class, here you have to put a semicolon, but with namespace, no. Let us straight away jump to a simple example where we'll see this how it works. Yeah. So have a look at this. We create namespace in a header file. I create a namespace called circle. We declare the constant pi and a library function called area of circle, which will calculate and return the area of the circle. Okay. Then we use the C++ program. In the name C++ program, we include the header file in which we have the namespace declared. And then we pull in the namespace also using namespace circle. Enter radius, entered. Area of circle is area circle, which acts as a library function declared in the namespace circle. And this will calculate the area from this radius and give you the result. Watch it. When I compile this, it compiles successfully, and there is a enter radius. 3 is the radius, and that is the area of circle. Simple and straight, isn't it? Yes, Ravi?
Yes, sir. Sir, why we need these custom namespaces? I mean,
You will
any
need,
benefit?
yes, for every application, you have to create your own libraries. For literally for every application, you need your own libraries. How would you create libraries?
Okay, it is kind of libraries in C++.
Every library in C++
Okay.
is placed through the namespaces so that there are no name clashes. There can be several instances of the same namespace. Like, see, I have created a namespace called namespace geo. Then I have created another namespace with the name namespace geo. You have two namespaces with the same name. This is not an error. You have created first namespace, okay. Then the second namespace. Now both the namespace will be, when used, will be merged into single one. So the pi will be used in the second namespace, which is taken from the first namespace, and vice versa. Both the namespaces will form a one big namespace. When you have the geo same name for two namespaces, this looks like a redefinition, but it's really just a continuation of the previous namespace geo. This allows a namespace to be used in several header files, which can then all be included in the source file and used as a one big namespace. Okay, have a look at this multiple namespaces. I have a namespace alpha in a file a.h, then another namespace alpha, same name, in another header file. So when you write a program, you include both the header files and include the namespace alpha. Then the function A and function B, both from two different namespaces working as a one big namespace, will be usable. You can have unnamed namespaces as well. One can create an unnamed namespace. Doing so creates a namespace that is automatically visible throughout the file in which it is defined, but not visible to other files. When you create unnamed namespaces, then the scope of the namespace is limited to the current source file. The scope of the namespace gets limited to the current source file. In every file that you want to use that namespace, you have to exclusively include that namespace by using the namespace keyword. The compiler gives an unnamed namespace an internal name automatically, which is unique, which is an alphanumeric name. Elements declared in the unnamed namespace can be accessed from anywhere in the file. Okay, like this. I have used the namespace, but in the file a.cpp, namespace without a name, in which I have declared some variable. Then the function A can use the global variable. In the function B.cpp, I have created a namespace in some header file, include that header file, and we can use the function B. Function B will be able to use the global variable, because the global variable will be found through the namespace, but only in the current file. Unnamed namespaces could be used and have the scope current file only. In this example which I showed you just now, both files contain the variable named global variable, but there was no conflict because each variable was declared in an unnamed namespace, which was unique to the file and was invisible to other file because of scope of the namespace, and the global variable was limited to that file only. This approach provides us with an alternative to the use of static for restricting the scope of the global variable to their own files, isn't it? In fact, the namespace approach is now considered preferable over static because it makes your data very protected also. That's all. Nothing else in namespace. Now, what more is left for us to do in the namespace is our own innovation. And this is all I had to deliver with respect to knowledge namespace. This is the multiple namespaces. Look at this header file. In this I have declared a namespace circle, another namespace circle. Both will be clubbed into one namespace. Here in this I have declared a constant and area of circle library function. Then the circumference of library function, like this, isn't it? Now you can use a program in which you can have both the namespaces included from this header file, and then enter radius and find the area of circle using this library function, and area of and the circumference using another library function. It will work perfectly fine. There you see enter radius, and there you have both the area and the circumference for you. Okay. Another example. The header file. The header file in which I have kept a namespace std and a class in which you have some private numbers and a multi-digit function and a multi-base 10 digit function, private functions. Private functions, remember, these private functions could be called only through the public functions, and the return type is very long object, zero argument constructor, which will set this very long string to null string and a very long variable to 0, which is the length of the string. Then you have one argument constructor which will copy the argument string to the private member VL string and find the length of the VL string and store it in length. Then you have another argument which is integer argument, which will take one argument integer long to ASCII conversion. This will be converted to ASCII and stored in VL string. Revert the string, reverse it and find its length. Okay, then you have some other functions also to display and to get the string, and some overloaded operators for concatenating strings and the repeating strings. So this is the header file that we have. Let's see how we use it. Yes, Ravi, tell me.
Yes, sir. Can you open that program again? Can you explain that?
The header
Sir,
file.
line number 14, 15.
These are private
Yes.
member functions. That's all.
But this is very long type. That means object.
Yes, it is returning objects.
Okay. Okay.
Then the main function is in main function. Can you see the main function? I can't see the main function. VLAP. Okay. Here it is. I create a very long object, and the name of object is fact, which is given the number 1. So it is going to invoke a integer argument constructor. This constructor would get invoked. 1 will come here, converted from ASCII to string and stored in VL string. It is reversed and its length is stored in V length. After that, we say enter a number. Enter a number. You enter some number, which is going to be a long number, big number. So j goes from number to 0, and you find the factorial of that number and display the factorial. Very simple, isn't it? And then you say put value. Put value function will display the factorial value. Put value function. There it is. It will create a local object and local string and copy the private string into this string, and then strrev reverse the string and print it. Okay, let's run it and then we'll come back to this.